Okay, I want to go over the two examples we didn't have a chance to get to today in class. The first one being about the migraines. This says that according to the CDC, 15.2% of American adults experience migraine headaches. Stress is a major contributor to the frequency and intensity of the headaches, and a massage therapist feels that she has a technique that can reduce the frequency and intensity of the migraines. We are asked in the first part of this question to set up the hypothesis, to determine the null and the alternative. In order to do that, we have to identify what type of parameter are we talking about, a p, a mean, or a standard deviation. We can see that because we are talking about 15.2% here, that's p, and that p would be equal to 0.152. Remember that our null hypothesis is always a statement of equality, so this becomes our null hypothesis. Now, how do we determine the alternative? The alternative comes from the last part of this paragraph that says that she feels that her technique can reduce the frequency. That's implying then that P would have to be less than that 15.2%. So that's what we're looking at when we set up the test, and this is indeed a left-tailed test. The next part of this question, or the problem that we're looking at, says, okay, well, if we have a sample of 500 American adults who participated in the program, and they indicated that the null hypothesis should be rejected. That's what the data came back and found, that the null hypothesis should be rejected. So we've got to be able to state that conclusion. Remember, I gave you a template for how to state that conclusion in class, and it talked about how you're going to state it that there either is or is not sufficient evidence to conclude that something about the alternative. So the way that we're going to look at that is by this, that there is sufficient evidence to conclude that the therapist's technique reduces the frequency and intensity of the migraines in 15.2% of the American adults. So if we reject the null, then what are we doing? We are saying that the alternative was true. If we reject the null, then we're saying that the alternative was true here. And we state that by that there is sufficient evidence supporting the alternative, which is what we're looking at. Now, the next question in here is in fact a little different from what you have because I have a typo on your paper. So suppose that the percentage of patients in the program who experience migraine headaches is in fact 15.2%. So it is 15.2%, which was the null. That's what we're saying. So we committed some type of error. In other words, the null was true, but we rejected it, didn't we? We rejected the null, which is the 15.2, when the null was in fact true, and that is a type 1 error. So we rejected the null when the null was true. In other words, the innocent went to jail, and that is in fact a type 1 error. All right, let's look at the next problem that we had here on our papers. It said that a can of soda is labeled as containing 12 fluid ounces, and a quality control manager wants to verify that the filling machine is neither over or under filling the cans. So we're going to come up with the statement for the null and the alternative. The only thing we're given here is that 12 fluid ounces is what we're looking at. This is actually that the mean, that mu, is equal to 12 ounces. Because we're talking about a statement of equality, that becomes our null, and the alternative in this case comes from the last sentence, that they want to verify that the machine is neither over or under filling, so that mean is not equal to 12 ounces, because if we're not either more than or less than, we are neither. And that is our test. This would be a two-tailed test when we get to the next section. Here in the next part it says the quality control manager obtains 75 cans and measures the contents. The sample evidence did not provide evidence that the machine is out of calibration. So we want to write a conclusion about this. if the sample evidence did not provide evidence that the machine is out of calibration, then technically we are keeping the null, right? Because what we're saying is we are rejecting the alternative. But we have to state this in terms of the alternative. So that means that there is insufficient evidence. So we're going to look at this like this. There is not sufficient evidence to conclude that the machine is either over or underfilling. This part right here that I just highlighted has to do with the alternative, and then we're saying that there's not sufficient evidence to make that conclusion. So now let's talk about the error. Suppose that in fact it is out of calibration by underfilling. So we want to determine whether a type 1 or a type 2 error has occurred. So if in fact it is out of calibration and it's underfilling, then we should have rejected the null. So we failed to reject the null in this case, right? Because our conclusion basically supported the fact that we were not underfilling, that everything was okay. But in fact, everything's not okay. We are out of calibration, so we should have rejected the null. We failed to reject the null. How do we state that? If we fail to reject the null, not how do we state that, but if we fail to reject the null, then what we have committed is a type 2 error, right? The guilty go free. So failing to reject is when the guilty go free, and that's a type 2 error. Now the last thing that we're talking about here says, okay, management has informed the quality control department that it does not want to shut down the filling machine unless the evidence is overwhelming that the machine is out of calibration. So what level of significance do you think that we should recommend to the quality control manager? Remember, level of significance had to deal with how high of a priority are the errors. Well, management is saying that we want overwhelming evidence that this thing is out of calibration. So I would say that you want a very high level of significance, because we want to make sure that we're catching all of these misses, right? So if I want a high level of significance, the highest level I can choose is the 0.01. And when we choose that, that's what we're really saying is that the chance of incorrectly rejecting the null is going to be very, very small, right? If we reject the null, we're trying to limit the size of that. And these are the two more questions I wanted y'all to be able to go over.